Welcome to lesson 3.2, adding rational numbers. Today we're going to talk about a couple different things, but we're going to focus on adding rational numbers, except for today we're only focusing on adding rational numbers with the same sign. And then, we're adding all of them starting with the same sign. So just addition today, and then solving real-world and mathematical problems that involve adding rational numbers. Now, these are also supported standards, solving multi-step real-life and mathematical problems, and applying properties of addition to calculate with numbers in any form. Okay, so we're focusing on these two standards here, 7NS1 and NS3, and then we're supporting the other two. So here we go, talking about adding integers, adding rational numbers. So the rules still apply. So you have to remember that when you have, and actually we'll pull this up real quick again. Okay, so adding same sign, you add and keep. Adding different signs, you subtract and use sign of greater absolute value. And then subtracting, change, we're not doing subtracting, so we're just focusing on the addition ones today. Got a little ahead of myself. Okay, so for example, Malachi hikes for 2.5 miles and stops for lunch. Then he hikes for 1.5 more miles. How many miles does he hike altogether? Right, so the signs are the same. So even though there's decimals in here now, the signs are the same, so the process is exactly the same. I take 2.5, I line it up. Remember, I line up my decimals when I add with decimals, and then I add. 5 and 5 is 10, carry the 1, 2 and 1 is 3, plus 1 is 4. Okay, so my answer is 4. The result is that he hiked 4 miles. So just because fractions and decimals are included now, that doesn't change the process. That just means that we have to be extra careful in terms of how we add. So when we add decimals, we have to line up the decimals, and when we add with fractions, we have to have common denominators. So for example, here we have Kyle who pours out, so out means it's negative, 3/4 of a liter of liquid from a beaker. Then he pours out, so that's another negative 1/2 liter. Okay, so the problem is -3/4 plus -1/2, because we're trying to figure out the overall change. So it's a negative plus a negative, but here's the thing. In order to do a negative plus a negative, with fractions, those denominators have to be the same. So in this case, and I know this is using the number line, this is just showing you how that works. What I want to focus on is the numbers. So 3/4 and 1/2. We need to find that common denominator. And the common denominator in this case is going to be 4. So the common denominator is 4. So I don't have to change the 3/4. That's all good. But 1/2 has to change to something with fourths. Well, I know to get to 4, I have to do 1 or 2 times 2, and what I do to the bottom, I have to do to the top. 1 times 2 is 2. So now, instead of adding 3/4 and 1/2, I'm adding -3/4 plus -2/4. Now I know that my signs are the same, so I can go ahead and add, and I get 5, and 4 stays the same, and it's negative. I add and keep. Well, 5 is bigger than 4, so I can make one group of 4 with 5 pieces. I have 1 left over out of 4. So then I have -1 and 1/4. So explain how to determine whether to move right or left on the number line when adding with rational numbers. So this goes back to the original problems with adding and subtracting, or with adding rational numbers. Remember, when you add with positive numbers, okay, so when adding positive numbers, you move right, or I'll say to the right, on the number line. When you add a negative number, you move left on the number line. Okay, so it's still the same. Adding those positive numbers tells you that you need to move to the right, and adding those negative numbers, so plus a positive, move to the right, plus a negative tells you to move to the left. Really the big thing here is remembering how to add and subtract fractions. So we're going to make sure that we focus on that a lot. So here we have 3 plus 1/2. And I know it says use a number line, so here we start at 3 and we're adding 1, so it's adding a positive, so we're going to go to the right. And we're going to go to the right 1 whole, but then we also have that half, so we have to go another 1/2, which gets us to 4 and 1/2. Okay, and now here I have negative 2.5, which is between 2 and 3, plus negative 4. So I have to go negative 4. So this is 1. So don't go to the negative 3 because that's only half. So here's 1, 2, 3, 4. Then another half gets us to negative 7. Again, to show that, since it's adding the same sign, you add the absolute values. And then you keep the sign. Remember, when adding with fractions, you have to get those denominators to be the same, and we'll do a lot of practice with that in class. Okay, when you're adding with different signs, again, you have to go, so we're adding a negative in this case. So when you're adding a negative, that tells you to go to the left. So if I start at 4.5, so halfway between my 4 and my 5, and I add a negative 7. So I have to go 1, 2, 3, 4, 5, 6, 7, and then another half. Okay, that gets me to negative 3. So remember, to do that, I actually subtract. I take the absolute values and I subtract them. But since negative 7.5 has a larger absolute value, I know my answer has to be a negative 3. All right, looking at this next one, we have negative $2.50 plus $6, okay, because he writes a check for $2.50, then he deposits $6 into his account. So he loses $2.50 and then gains 6. Well, since the signs are different, so we have a negative plus a positive, so I'm actually going to subtract to find my answer. So I'm going to do 6 minus 2.5. Okay, so I'm going to add a decimal and a 0 here. 10 minus 5 is 5. 5 minus 2 is 3. Bring down my decimal. 6 has the greater absolute value, so I know that he has that $3.50, or it was actually an increase of $3.50. Again, use your rules, but now we're adding the idea of fractions and decimals. So negative 3 plus 2 and 2 plus a negative 3, do they have the same sum? And does it matter if the negative number is the first addend or the second addend? So in this case, you want to look at negative 3 plus 2 and 2 plus a negative 3. Think of your properties, right? So with addition, we know that we have the commutative property. The commutative property tells us that we can move our numbers around in any order and still get the same result, okay? So the order of the addends, and let's look at this. So negative 3 plus 2, I'm still going to do 3 minus 2, and I'm still going to get 1. 3 is still the larger absolute value, so my answer is still negative 1. Here, I'm going to do the same thing. It's still going to be 3 minus 2. I'm still going to get 1. Negative 3 still has the larger absolute value, so my answer is still negative 1. Again, the commutative property tells us that the order does not matter when adding positive and negative rational numbers. And we can add that part in there. So the commutative property allows us to move numbers when adding. So the order of negative and positive numbers does not matter in addition of rational numbers. All right, and now I want to have you think about this one. Do you think the sum of a negative number and a positive number will always be negative? Now remember, sum means the answer to an addition problem. So think of your addition rules. You're going to answer this one on your own, and it's going to be a discussion problem in class. All right, so be ready to explain and defend your reasoning. All right, so now we have negative 8 plus 5. We're not going to use the number line. You should be able to use the number line at this point. I want to practice without it. So we have a negative and a positive, so I know that I have to do subtraction. So I'm going to subtract 8 minus 5, and I get 3. So 8 is the larger absolute value, so my answer is negative 3. 1/2 plus negative 3/4. In this case, my denominators are not the same, so I have to make them the same. So between 2 and 4, the least common denominator, okay, so I know that 2 can multiply to get to 4, so I'm going to change 1/2 to equal something over 4. I know that 2 times 2 gives me 4, so what I do to the bottom, I have to do to the top, and I get 2/4. So my new problem is 1/2 plus negative, scratch that, I changed the wrong one. 2/4, there we go, plus a negative 3/4. Well, my signs are different, so I know I have to subtract. So I do 3/4 minus 2/4. My denominators are the same, so I can subtract. 3 minus 2 is 1. My denominator stays the same, but 3/4 has the larger absolute value. Okay, it's further away from 0, so my answer in this case is negative 1/4. And then number 8, 7 minus 1, because the signs are different, but 7 has the larger absolute value, so my answer is a positive 6. To be completely honest with you, we're going to fly through this part because you guys are amazing with opposites and additive inverse. We know that the opposite of a number is a number that's the same distance from 0, but on the same distance from 0, but on the opposite side. So even though we're adding decimals into this, even though it's negative 3/5, the opposite is still going to be positive 3/5. It's still going to, not 3/5, 3 and 5/10. It's still going to take us 3.5 to get back to 0 from negative 3.5. All right, so I feel like this is all pretty good with us. You can go through and read the problems, but again, the opposite of a number is literally just the same number, but on the other side of 0. So if it's a negative number, so a positive 3/4, the opposite is going to be the negative 3/4. Okay, because it's 3/4 away from 0, but on the negative side. It's not just integers that works for. Okay, so now we're going to find the sum. Well, let's take a look at this. I have a positive 2.5 and a negative 2.5. So if I go 2.5 away from 0 and then add a negative, so that tells me I have to go back, I know that that's going to get me to 0 because they're opposites, they're additive inverses. Again, if I start at negative 4.5 and I add a positive, that tells me to go to the right. And if I do that, that's 1, 2, 3, 4.5. Again, it gets me back to 0 because they're opposites. All right, so now we have examples where we're adding three numbers at a time. All right, so Tina spent $5.25 on craft supplies to make friendship bracelets. So she spent the $5.25, so you know that that's a negative. She made, so that's going to be a positive, $3.75 on Monday. And then on Tuesday, she sold an additional $4.50 worth of bracelets. Selling bracelets means that she got money. Okay, so we want to know what was her overall profit or loss. So we have to go in order. So we started out by losing, so a negative $5.25, and then gaining, so we added the positive $3.75, and then we also add a positive $4.50 because she sold that and made that money. So now here, our positive numbers are already together. So instead of doing a negative plus a positive and potentially getting a negative number, we can move our numbers around thanks to the commutative property. We can move our numbers around and we can make it easier for us to add. So in this case, we don't have to move the numbers, but the associative property allows us to group them and add in whatever order, because 1 plus 2 plus 3 is going to give us 6, and 3 plus 2 plus 1 is also going to give us 6. So the order doesn't matter because addition is all going that same, it's all doing the same thing. So here, I'd rather add my two positive numbers, which got me a positive $8.25, and then only add two different signs once so I don't have to get all confused. Okay, and then I know that when I do that, I actually do 825 minus 525, and I get $3. So she had a profit of $3. Okay, so let's take a look at 11. So I want to add both of my positives together first, so I don't have to do negative plus a positive and then possibly have to do another negative plus a positive. So let's add our same sign numbers first and make it easier. So negative 1/2 plus 3.5 plus 2. Well, 3.5 plus 2, I know is 5.5. Now I know my signs are different, so I actually have to do 5.5 minus 1.5, and I get 4. 5.5 has the greater absolute value, so my answer is 4. Okay, for the second one, I'm going to add my negatives together first this time. So I have 3 1/4 plus negative 2 plus negative 2 1/4. The nice thing here is there's only one fraction, so I just add my whole numbers. So why do I keep doing that? That is not part of the fraction, that is the integer. So that's 3 1/4 plus negative 2 plus a negative 2 is a negative 4 1/4 because I have the 1/4 over here. Now the nice thing is my denominators are the same, so I don't have to mess with that. But my signs are different, so I do have to do 4 1/4 minus 3 1/4. Here I get 0/4, and here I get 1. 4 1/4 has the greater absolute value, so my answer here is negative 1. All right, so then number 13, I have negative 2 7/5 plus negative 3 25 plus 5. So I'm going to add my negatives first, and I get, so 5 and 5 is 10, carry the 1, 2 and 7 is 9, plus 1 is 10, carry the 1. 3 and 2 is 5, plus 1 is 6, so I get a negative 6, because I have the same signs, so I add and keep, plus 5. Well, here, since my signs are different, I do 6 minus 5, and I get 1. 6 has the larger absolute value, so my answer is a negative 1. All right, and then 15 plus 8 plus a negative 3. It's a good thing I only have one left because I'm running out of space. 15 plus 8 plus negative 3. I'm going to add my positives first, so I get 23 plus a negative 3. I know that adding different signs means that I subtract. So I get 20. 23 was further away from 0, so my answer is positive 20. I know this is a lot, all right, and I know it's difficult, but we have to take our time and practice. I promise you we'll get plenty of time with practice with this as we have a long Module 3. Make sure that you finish the guided practice, and as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.